Humans have become one of the most powerful forces shaping life on Earth. In just a few centuries, our population, industries, and technologies have transformed landscapes, altered global cycles, and driven thousands of species toward extinction. Today, we'll explore how modern civilization impacts the biosphere, from pollution and climate change to biodiversity loss and environmental recovery. Modern industry and agriculture operate on massive scales, and while they fuel human progress, they also introduce vast amounts of pollutants into the environment. Factories release heavy metals, plastics, and chemical byproducts into air and water systems. Agriculture contributes large quantities of fertilizers, pesticides, and animal waste that run off into rivers and oceans. Excess nitrogen and phosphorus from fertilizers cause eutrophication, algal blooms that deplete oxygen and suffocate aquatic life. Meanwhile, industrial carbon emissions and persistent organic pollutants accumulate in ecosystems, entering food chains and even human tissues. These activities remind us that technological advancement without sustainable oversight can destabilize natural systems. Now, let's assess one of the most urgent consequences of industrialization: global warming. The scientific consensus is clear. Rising levels of atmospheric CO₂ from burning fossil fuels are trapping heat, leading to the greenhouse effect. Carbon dioxide, methane, and nitrous oxide act like a thermal blanket around the planet, preventing heat from escaping into space. The result is an increase in global average temperatures, melting glaciers, rising sea levels, and more extreme weather events. Ice core data and satellite measurements confirm that today's CO₂ concentrations are higher than at any point in the last 800,000 years. The connection between human activity and climate change isn't theoretical. It's observable, measurable, and accelerating. Biodiversity, the variety of life on Earth, is declining at an alarming rate. The three main drivers are habitat destruction, introduction of invasive species, and overexploitation of resources. Deforestation for agriculture and urban development fragments ecosystems, leaving species without the space or food they need to survive. Invasive species, whether introduced accidentally or deliberately, outcompete native organisms and disrupt ecological balance. Finally, overfishing, poaching, and unsustainable hunting push many species toward extinction faster than they can recover. Each of these factors is amplified by climate change, creating a feedback loop of ecological decline. Among Earth's resources, some are truly irreplaceable. Consider freshwater, topsoil, and biodiversity itself. Freshwater supports all forms of life, yet less than 1% of Earth's water is readily available for human use, and much of it is being polluted or overdrawn. Topsoil, essential for agriculture, forms slowly through weathering and decomposition, but intensive farming and erosion are stripping it away faster than it can regenerate. Biodiversity, the living library of genetic diversity, underpins ecosystem resilience, medicine, and food security. Once a species disappears, its genetic potential is lost forever. The growth of the human population over the last 10,000 years has been nothing short of exponential. Around the time of early agriculture, there were roughly 5 million people on Earth. By the dawn of the Industrial Revolution, that number had climbed to about 1 billion. Today, we exceed 8 billion, and counting. This explosive growth puts immense pressure on natural systems. More people require more land, more food, more water, and more energy, leading to deforestation, urban expansion, and increased carbon emissions. Population growth is not inherently negative, but without sustainable planning, it multiplies every existing environmental challenge. When designing recovery plans for endangered species, scientists first examine the cause of the species' decline. If habitat loss is the issue, conservation may involve land protection or restoration. If overhunting or poaching is to blame, legal protections and enforcement become central. In cases of invasive species, the focus shifts to ecosystem management or reintroduction of native populations. Each recovery plan is tailored. There's no one-size-fits-all approach. Success stories like the American bald eagle and the gray wolf show that when recovery strategies address the root cause of decline, populations can rebound. Not all human impacts are destructive. Lake Washington, near Seattle, once suffered from severe pollution due to sewage discharge. In the 1950s, citizens, scientists, and policymakers collaborated to redirect waste and restore water quality. Within a decade, the lake's ecosystem began to recover. Similarly, the Nashua River in Massachusetts was once choked with industrial dyes and waste. Grassroots activism, led by conservationist Marion Stoddart, mobilized community and government action. Through persistent advocacy and policy reform, the river was revitalized, an inspiring example of how local action can drive ecological renewal. Human influence on the living world is profound, sometimes destructive, sometimes redemptive. We have altered the chemistry of our atmosphere, reshaped entire ecosystems, and driven species to extinction. Yet, as the restoration of Lake Washington and the Nashua River shows, our capacity for innovation and collaboration can also heal the planet. The challenge of the 21st century is to harness that power responsibly, to live as stewards, not conquerors, of the biosphere we all depend on.